acknowledge first there's been a lot of people involved in it. HIVE, let me just move on here. HIVE is about making data discoverable, interoperable, usable, reusable, and it's a technology and an approach, and the focus is on what we call semantic metadata. You can think about indexing data or assigning metadata, semantic metadata to represent data, and rarely is one, we say, controlled vocabulary or semantic ontology enough. For instance, you may have a data set and you need geographic information, taxonomic information, topical information, and often you need multiple types of topical information. So that's part of the motivation. The next is that your taxes and my taxes are paying for the creation of ontologies. There are hundreds of ontologies out there. A lot of them are being created by federal agencies, and increasingly they are being published on the web and published in linked data format and available for machine activities. And so taking advantage of that and the fact that people in indexing, it's costly to have one person individually curate working with multiple vocabularies. HIVE uses the automatic approach to integrate these existing ontologies or ontologies that you may be creating in-house, but that create in a linked data, semantic web type format. So the acronym is, I love it. You can think about the little B going out to the different vocabularies and bringing back the right terms or concepts to semantically represent your data. So let me, this is just an example of sort of the architecture, and I think I pretty much said this already, but HIVE allows users to search and apply terms for multiple vocabularies or semantic ontologies. HIVE does use machine learning. I'm going to say a little bit more about HIVE 1.0, which worked with Kia and Kia++, which is a machine learning algorithm that came out of Waikato University. And Joan's going to talk more about new work, and we're moving HIVE along that you could actually plug in different machine learning algorithms depending on your types of data. And so HIVE also just encourages interoperability. So HIVE 1.0 is dating back a while here, but this is just to give you a picture of it. So the home page here, and you can see you can register multiple vocabularies. And this is the HIVE demo. You can take the HIVE technology and approach and put it into your system, and it will look very different. For instance, the LTER, Long-Term Ecological Research Network, uses HIVE technology daily, and their interface does not look like this, and they have different vocabularies than what's registered here. The next here is an example of the concept browser where you could select multiple vocabularies and search in one fell swoop, right, your concept. So here's a search for the word precipitation in Agravoc, which is a vocabulary that comes out of the UN Food and Agriculture Organization, LCSH, and you see the keyword in context for precipitation. And then there is the third approach, which is the automatic indexing approach. So you see the little green dots here in this HIVE 1.0. One is you select your terminologies. Two, you choose your file, or you can put in the URL if it's URL at the time if it was something on the web. And three, you start the processing. As I said, HIVE's been around for a little while, and the original demonstration grant that we had was actually IMLS in the Dryad project. And so here's just an example. Amy Zane and other scientists published an article, and they're putting their data into the Dryad repository. And I'm just going to kind of assume most people have heard of Dryad, but it's a repository for data underlying published research, and I've been very involved in that. So the scientists go to the HIVE, select the vocabulary, and in this case, this example is just 3 vocabularies and comes out with a tag cloud. Some of these terms are very good, and clicking on them and assigning them to as metadata to represent the data is good. Some of these terms are not so good, and that has to do with the machine training that we could do a better job at. Just in the interest of time, here is an example of what the original architecture looked like. combining several open source technologies. It was Java-based originally. What you've been looking at is the demo site, the original demo site, and we'll give you an update there. And the code was originally on Google. We've moved it over pretty much all the way over to GitHub. And I'm sorry, I don't have the correct URL there. Mike is going to say a little bit about HIVE in IRODS actually in a minute. But just to show you, here's Joan had to do a demonstration at RENCI, and we just put in several ontologies here. And you know, the time, you have to think about the time it takes somebody to look on multiple vocabularies. It's ridiculous. We shouldn't be doing that. This stuff is all machine readable, and we should be able to have some kind of interaction here with at least the person ultimately selecting the term. So, Mike, do you want to just go with your slides now for a few minutes?
Yeah, can you drop that's terrible, Joan?
No, just does it. So we're doing tag teams.
And the slides I actually sort of did in the previous meeting, so they're essentially crayon drawings.
All right.
But I wanted to just kind of put in the context of how HIVE fits into where we see the system. So next one there, Joan. So the whole idea here is that on the DFC side, at the core is that IROD server, and it's not really good for doing discovery, but what it's really good at is being like sort of the canonical data and metadata repository. So you can have policies that control both of those things. So the stuff is always there. And then we can treat indexes as ephemeral, so we can project different parts of the grid out to different indexes. So you might have this collection being indexed through Elasticsearch. You might have another collection that is indexed and put into a triple store. And this is where HIVE fits in, is specifically in this area of semantic metadata, linked data, and also being able to have triple store representations of the data inside the catalog. So that's the point of that. And then the next slide. So where HIVE comes in is you can have policies that describe metadata templates. So any data in this collection has to be curated with certain kinds of metadata, which can include curation. For example, you must apply n number of terms from these vocabularies, or these vocabularies are suggested for human curation. Okay. The idea would be, okay, we want Agrabah and we want Mesh as available vocabularies, and curators can be queued to search across those vocabularies to find applicable terms. They're applied to the data, and then on the application of those terms, on the editing of metadata, on the ingest of new data and automatic extraction, terms can be applied from HIVE, which can then trigger indexing into, for example, a triple store. Next slide. Okay, and the whole point of this is really the nugget here is this idea of virtual collections. And this is based on the idea that you can federate these grids. So we have a global namespace, and then here we're using HIVE, and we're marking up collections with semantic terms from vocabularies that the HIVE service provides. HIVE provides, again, the tools for human curation, as well as tools for automatic extraction of terms using natural language processing, which seems to fit really nice into what Brown Dog is contemplating. But the idea is you can federate with another site who is also using vocabularies applied to their collections. These two institutes can then federate together, and you can then index across the data in both those collections and project that into an index. And then, for example, you can do a Sparkle search, and you can actually see data that is spread across distributed collections using a tool like Sparkle. And they appear and behave as one collection. And I think the really cool thing is, for the folks that were at the Northeast Hub, what I'm most excited about is taking this exact concept that Jane is talking about and doing things like applying data sharing agreements as computer actionable policies between these nodes in the federation. So you can have one collection from the outside user, looks like one coherent collection. It's actually distributed geographically between organizations that maybe have agreements in place. And then you can find those terms using tools that real people use, because real people are not going to use the dumb query language in IRODS. They're going to use Sparkle or Elasticsearch or something like that. And so, again, that's kind of like I've only mentioned HIVE in passing, but the idea there is this is why we were interested in HIVE, because if we didn't have a tool like HIVE, we would have to build it. And so then Joan is going to talk about how we're going to save the world. So in short and sweet, that's where we see the very important place of HIVE. And we're doing rich search, so you can search by near terms or parent terms or things that are like this term. And how amazing is that? Okay.
I don't know about saving the world here, but that's a tough act to follow there. What I do want to talk about, though, primarily is what we're doing now with the current version of HIVE, the HIVE 2.0. So this is basically a rewrite, redesign of HIVE 1.0 that we started last summer. Time flies. These are just, snapshots of what Jane just showed you in the HIVE 1.0 version. This is a Java implementation that runs on a Tomcat server. There are probably, I don't know, at least 4 different types of data stores underneath this, multiple APIs. And needless to say, it is rather complex. One of the obstacles I think that we ran up against was that it was becoming increasingly difficult to enhance and improve and add capability to HIVE 1.0. And one of the reasons for this was in part because this was developed, this version of it I think was wrapped up around 2011, 2012. A lot of those Java libraries that it's built on are updated. Mike tells me the source code for some of them isn't even available. So the effort to upgrade all of these libraries is significant. That and the fact that it is not a very extendable modular design under the covers. So the other issue that came about, and this is one that I think Jane encountered, was that we were running into difficulty finding Java-skilled programmers. It seems these days that everyone is jumping on the Python bandwagon, and probably with good reason. It is the class I teach over at UNC. It is a relatively easy language relative to Java. It is an interpreted language unlike the compiled Java language. But I have to say it is easy to pick up. I think it's going to be easier to find folks to work on this. And the other thing that's really important is that there are an awful lot of really good Python libraries that are emerging to handle text processing, natural language processing. So there's no shortage of library support for the Python language. So we made the decision, I guess it was last summer.
Yeah, we really agonized over it.
We did. We had many a discussion. Do we stay with Java and find best?
And a lot of the linked data stuff is also happening in that area.
In Python. So a lot of it, though, was just addressing the skills availability to keep going, to be able to extend and to be able to have more of a plug-in architecture to add new algorithms and vocabularies. And one of the things I know that's always been an issue is being able to import vocabularies into HIVE 1.0. It's a difficult, time-consuming, somewhat painful process.
Yes.
It is not something that you can easily hand off to someone who does not have development experience. So that is something that has always been an effort that we've been focusing on. And that has been simplified a fair amount because more of these libraries do seem to be supporting the RDF format, the resource description format. So if you can at least have a common format, that's one substantial head start to being able to simplify this import process. And also the data model. HIVE 1.0 has 4 different data stores. We have one. That doesn't mean that we won't need to add others as we continue with this. But start small, start fast, make it work. The other thing that we need to do is just to improve the web services. There is a REST API for HIVE 1.0. That is what we have Dockerized and given to Mike. So that API is available, but the intent here is to do the same thing with HIVE 2.0 and improve the interface. The one for the Java version is a little bit cumbersome. It could be a great deal more streamlined for the non-developer to use. And then what I mentioned before, one of the things that drove the decision to redesign in Python was actually the availability of all these tools and libraries, i.e. a whole lot less code for us to write. Okay, leverage what's already out there. HIVE 1.0 runs on Tomcat, which is a very powerful web and application server. There is a very lightweight web framework available in Python called CherryPy. This was referred to me from another faculty member at UNC who has used it before. So far, so good. The Drexel administrative support has been wonderful in getting this up on their server. So it's working pretty well so far. There is the natural language toolkit, which does a lot of the heavy lifting in terms of actually, processing documents, doing the parsing, the stemming, the filtering, classification. So we don't have to do that. This version of it does not use the Kia or Maui algorithm that was used in HIVE 1.0. That is a very robust algorithm. It, I think, looks at something like 15 different features of each keyword that it extracts in order to rank the relevance, thank you, as a keyword for metadata generation. So we didn't use that. We did actually contact them to see if we could find out about getting a Python version, but that wasn't in the works. But that would be a good thing to do, is to try to Pythonize the Kia algorithm. But the author of that actually had taken a look at this rake algorithm. And she said, actually, I think that it was pretty good, but it needed some enhancements. But rake is fast. It probably only works with maybe 3 features when it tries to evaluate the ranking of a term, but that's a good start. And the code is available there, so you can add what you want to it. It's basically open source. RDF Live has been invaluable because the vocabularies that we've imported into HIVE 2.0 so far were all in RDF format. RDF Live did most of the work. Didn't have to write anything. And then SQLite, which is a very lightweight relational database, which you probably all have on your phones and on your laptops, it's pervasive, is what is being used here for this version of HIVE 2.0. This is very much modularized with an API, so if you had to scale up to a larger database, that can easily be done, but we're starting out with SQLite. So these are intended to be just a few screenshots to show you how, at least from this demo page, how it mirrors the same functionality in HIVE 1.0. This is the home page. If you have the slides and you click on the blue link, it will take you to the demo. This is a list on this home page of the vocabularies that have been imported into 2.0. So it's a little hard to read, but it's the Unified Astronomy Thesaurus. I think the next one is the U.S. Geological Survey. There is a metals vocabulary that one of Jane's students created for us, and then the last one has to do with smart appliances.
Oh, yeah, good.
Yeah.
Smart technology.
Yeah, that was one of the ones you gave me.
Yeah.
So all these vocabularies were in RDF format. It's very easy. You go to these websites, they give you a link, you download the file. I wrote some I wrote some Python code to use the RDF Live library to process these. And basically they go through, parse all the content, and they generate actually a very large graph database. The graph database of triples. The triple structure defines the concepts and their relationships. It's also a pretty big database. So my first test was actually with the Unified Astronomy Thesaurus, and that has, I think, something like 1,800 concepts, and I don't remember the number of relationships. But the graph database that got generated was about 90 meg. It also had 30,000 plus triples in it. So I started looking through it and going, this is an opportunity for, improvement here. Because 90 meg is kind of big. And I realized that an awful lot of the triples had nothing to do with what HIVE was doing. It was really kind of extraneous information for our purpose. So I did pull those triples out, but then I also took the graph database and I just converted it to a relational database. It's a very simple database with 3 tables, I believe. And when I did that, it became 1.1 meg and it had 4,000 triples. Yeah. And it's fast. Okay, so that's not to say that in future requirements might mean that some of those triples have to come back in, but it's not a difficult thing to do to do the conversion from the graph to the relational. So that was actually one of the nice improvements from HIVE 1.0, where we got it down to 1 database, a small database, because some of the HIVE 1.0 databases are quite large. This is the Browse Vocabulary page, again, similar to 1.0. You select a vocabulary on the left-hand side, you're going to see a hierarchical view. It's a tree structure. All of these vocabularies that come from RDF are hierarchically organized. Most of them are organized around top concepts. So the vocabulary definers or authors themselves define the top concepts of the vocabulary, and we use those, okay, as the starting points. There usually aren't very many of them, maybe 20, 25 at the most. In this example, you can see that I've used the USGS one. The highlighted term in there, when you click on it, what you're going to get on the right is the detailed information. So from RDF, you get the preferred label for a term or a keyword. You get alternate labels. You get notes if they've been provided, broader concepts, narrower concepts, related concepts. So you can then select inside of those. I'm not sure if I'm going to lose one. This is an example. This is the actual demo. This is the Unified.
Yeah.
I'm sorry, I say it wrong every time. Unified Astronomy Thesaurus. If you look at the Big Bang Theory, you can come over here and find a little extra information. This is a broader concept. These are narrower concepts. So you can go through and basically, you know, if you're looking for particular terms or you want to confirm that the term that is being used for metadata is correct, you can get this detailed information about it.
That is fast, yeah.
It is
nice.
Yeah, I mean, this is running off Drexel
It's just,
server.
And Joan just launched this last week.
Sweet.
Yeah.
Well, I have much help. I have to say the sysadmin at Drexel has been wonderful because we had some logging issues and that were not related to the code. But,
So we are, got 5 minutes left.
okay, searching vocabularies, and I think we talked about this before. This is just a case where you can pick the vocabularies that you want to search from. You enter some kind of, you know, concept, keyword, or whatever. It does a wildcard search, and it's going to list over here the different vocabularies that have a concept that contain that search term.
That replaces the tag, yeah.
And then here's indexing, and again, this is very similar to what we were doing before. Again, you select the vocabularies of interest, you enter the URL for the web resource of the document, you click index, and this is the word cloud, and this just shows which keywords were selected, and you know, it's like a regular tag cloud where the font size indicates the ranking. Lastly, and this is just sort of my own kind of working set of next steps, I do need to harden the Web Services API. It is a REST API right now. The browser has a lot of JavaScript that issues AJAX calls. There's a REST API on the back end, talks to Python. Python talks to the database, generates JSON. That gets sent back, and it gets converted to the web page. That API does need to be hardened for use, you know, by Mike's Dockerized structure, but I haven't done that yet. That's coming. Okay. I do want to add machine learning because that was in the original version.
Yeah.
But there's libraries for that to plug in.
Right.
And then that'd be neat to get into Brown Dog too, just to kind of show how all these things can flow into each other. That's what I really hope for. Yeah.
Thinking we have Howard here too who worked on it, right? Get Howard back in.
Oh,
How's your Python?
I don't think I want to tell you.
So with 5 minutes left on a Friday afternoon.
Okay,
And that's
great. Thank you.
Wonderful. Thank you so much. Does anyone have any questions for the 3 presenters?
So in HIVE 2.0,
If we can't hear you, you got to come near the mic so everyone on the line can also hear you.
all right. Not exactly like pick on a Friday afternoon. So does this, in HIVE 2.0, does it still have the capability where you put a, like a, you know, a paragraph in and it would tell you which ontology it's most likely to be?
Yeah, it will, but it will be sort of a wild card selection of it, but it really focuses on keywords and phrases as opposed to a paragraph.
Huh.
So.
But you put that paragraph in and then it will parse it, right?
And then suggest those cost terms that apply.
Oh, I'm sorry, you mean a paragraph as in it being the document from which you're going to do. Yeah. But it has to be in a text file.
So how many vocabularies have you tried loading up?
I've only got 4 at the moment.
Yeah. Remember, I always thought we should load in 1,000.
Yeah, the mega hive.
Yeah, that's right.
So,
Still think it's what y'all are
well,
doing.
the thing about HIVE is just to remember, so you can have your own HIVE. Anybody could take the approach and the technology, and I said, like, the LTER folks use HIVE. You know, I don't know how often they use it, I have to check again, but they have their own HIVE. It looks very different.
Yeah.
Dryad has an instance of HIVE, and it's a prototype. There's some legal group in Italy that's using it, and they have their own vocabularies, but the demo HIVE could be a service.
Yeah.
You know, where we have, like, lots of vocabulary.
No, and that is next step. It's my last one, add more vocabulary.
Yeah.
Need to put in Library of Congress and see how that works, and mesh.
Neuroscience, that's my particular interest at the moment.
Others? Questions?
Any other questions? I will have questions, but I know you and I are following up by phone afterwards. I do want to say we right now have on the books Mike Conway and Kenton doing additional demos on December 9th. I'm going to be out of town at the IEEE Big Data Summit and other conferences, and given it's the holidays, would people want to postpone those demos to the new year? Okay, Mike is nodding yes. Kenton, do you feel okay postponing the NDS to the new year, and Carl can work with you to set up a date?
That's fine with me too.
Excellent. All right. Well, I want to thank everybody, but if you still have questions for the presenters here, feel free to continue. It's just I have a next call I'm going to have to jump on. Thank you all. This was fantastic. I really enjoyed it.
Kenton, Cheryl, Jane. Bye-bye.